When a recent iOS update makes your local LLM crawl or fail, it feels like broken code. But this is an engineering bottleneck where security mechanisms force impossible trade-offs between precision and latency. The narrative isn't that your app is buggy. It is that the hardware-software handshake has changed to prioritize privacy over speed. Today, we connect that headline to the real-world constraints you face when deploying AI on-device, and why a simple patch cannot fix what is now a fundamental architectural ceiling. Developers are reporting that their locally hosted models like LLaMA suddenly run at half speed or crash entirely after system updates. This confusion stems from treating the issue as a software bug rather than a hardware constraint imposed by security architecture. Apple's design keeps data on device to ensure privacy, but this creates a black box where neural network precision is sacrificed to satisfy strict privacy guarantees. Research from the Hasso-Plattner Institute and TU Darmstadt confirms that these mechanisms force significant performance penalties compared to standard deployments. The result is a direct increase in inference latency that developers must now account for as a baseline cost of on-device security, not an anomaly. The core conflict arises because the very binaries designed to protect your data are actively degrading model performance. When you run a large language model locally, the system enforces strict isolation to prevent weight extraction by malicious actors. To maintain this trust boundary without exposing sensitive information, the processor must reduce numerical precision or insert computational overhead that slows down every single inference step. This is not a software glitch. It is an intentional design choice where security takes precedence over raw throughput. You are witnessing a system that chooses safety first, leaving you with slower responses and reduced model fidelity as the price of admission for running AI on your own hardware. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. However, there is a hidden danger in trying to work around these speed limitations. Some attempts to optimize performance involve using pre-computed noise or other shortcuts within trusted execution environments to bypass latency checks. A study from Rutgers University reveals that this strategy creates critical security flaws rather than solving the problem. Attackers have successfully exploited patterns of static keying material and pre-computed operations to recover secret model weights in as little as 6 minutes per layer on models ranging from 8 billion to 405 billion parameters. What looks like a speed boost is actually a false economy that opens your application to weight extraction attacks, turning your secure environment into an open book for adversaries who know where to look. This vulnerability paradox means that relying on opaque security systems can alter how you make engineering decisions. Academic research indicates that when developers treat system predictions as infallible authorities due to their perceived security status, they often forgo better optimization strategies or ignore warning signs. In a recent study involving over 1,300 participants, more than 40% treated the AI prediction as an authoritative predictor of outcomes. This behavioral shift led to a 349 times increase in odds that developers would make suboptimal choices, resulting in financial or performance losses ranging from 10.7% to 42.9% compared to those who maintained skepticism and independent verification protocols. Beyond the software logic, there is a hard physical reality that no amount of code manipulation can overcome. Attempts to circumvent these limits via software spoofing demonstrate that the bottleneck is not just logical, but deeply rooted in silicon architecture. While tools exist to trick iOS into allowing an update on older devices like the iPhone 11 through 14 Pro, core AI inference remains inaccessible because the specific neural engine hardware required for these security-compliant workloads does not physically exist in those chips. The system may download the feature, and you might see a prompt indicating success, but without the dedicated silicon designed to handle the complex matrix operations of modern TEE-shielded models, the device simply cannot execute the workload efficiently. This creates a scenario where software is ready for prime time, but hardware refuses to participate in the performance dance required for real-time inference. The implication for your career and project planning is profound. You are now operating in an era where security by default has tangible costs that must be weighed against user experience requirements. If you deploy AI on-device without understanding these constraints, your application faces a binary outcome. You can either accept reduced precision and latency spikes to maintain strict privacy guarantees within the black box, or you must architect around these hardware limitations entirely. This often means offloading inference to the cloud where security models differ, or investing in newer hardware with dedicated neural engines designed specifically for these TE workloads. The choice is not about finding a better patch. It is about selecting an architectural path that aligns your privacy requirements with your performance expectations. For practitioners building secure AI systems, this research proves that shortcuts are dangerous and physical limits are absolute. You must understand the difference between theoretical security promises and actual implementation vulnerabilities when designing for on-device deployment. The 6-minute attack window identified by researchers shows that speed optimizations can be weaponized against you if they rely on static material reuse. Similarly, the latency penalties reported across major studies confirm that privacy comes with a computational tax that cannot be ignored in production environments. Your engineering judgment now requires evaluating whether your use case justifies the trade-off between absolute device-side security and the performance degradation it inevitably causes. The path forward involves making informed architectural decisions based on these hard constraints rather than hoping for future software patches to solve hardware limitations. You must decide if your product needs the highest level of privacy at the cost of speed, or if you need faster inference that requires a different security posture entirely. This is not just about an Apple update. It is a case study on the cost of modern AI engineering, where every feature has a measurable impact on system behavior and developer workflow. As these standards evolve, your ability to navigate these trade-offs will define the reliability and success of your applications in an increasingly secure but constrained ecosystem. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.